Hello everyone and welcome to today's webinar. I am Benoît Ferraud, Product Marketing Manager at Quarks Lab, and today's topic will be how to achieve PCI CPoC compliance. Here is the agenda of the presentation. So first we'll begin with a short introduction on the subject, on today's subject, PCI CPoC. Then we'll go over to the two certifications that exist nowadays on acceptance for mobile platforms, which are PCI CPoC and PCI SPoC, and we'll go over the differences between the two. Then we'll have an overview of what composes a PCI CPoC solution. Then we will see the security challenges which are inherent to a CPoC solution and how the requirements answers them. Then we will see what is application hardening and how it can be applied to a CPoC solution. And at the end, we'll have the conclusion and a round of question and answers. If you have any question during today's presentation, do not hesitate to ask them in the corresponding module, and we will answer them at the end of the presentation. But first, before delving on with today's webinar, you may not know Quarks Lab. So Quarks Lab, we are a French cybersecurity company, which was founded in 2011. And the core of our activity is the research and development, as 80% of our engineers' time is dedicated to it. So for us, research and development is used to pave the way for future innovations that will be used in the developments of our product and services. So for our products, we have two. IRMA, which is an automated file analysis platform intended for cert operators and security teams, and EPONA, which is a code data and keys protection software that can be used in the payment sector, for example. We also provide services, security services, for example, security audits on the hardware and software security, so for connected objects, for example, or cryptographic libraries. We have no more than 70 employees and growing thanks to a successful fundraising that we did last June. We successfully raised 5 million euros to fuel our developments for products. Okay, so today's topic, how to achieve PCI CPoC compliance. But first, mobile payment spending in 2010 was considered to be around $53 billion, and it grew tremendously over the years. And in 2017, it attained $721 billion, which represents an average growth each year of 45.2%, which is rather impressive. But we can ask ourselves the questions, while mobile payments are rising, why is there very few solutions at the moment about payment acceptance on mobile platforms? It's rather limited. And we have seen some pilot initiatives since 2017, especially in emerging countries, to test the waters about use cases and in the interest of such solutions. So why it's like that? And it's mainly because of security reasons. As using mobile platforms as a mean of accepting payment and processing transaction, it's a shift for the payment industry, because with traditional payment system, you have trusted and purpose-designed peripherals. These are peripherals which are built with one feature in mind, accepting and processing a transaction. And in this sense, they are designed for it with a lot of security features, both hardware and software, which made them very resistant to attacks. Whereas with a mobile platform, such as a smartphone or a tablet, for example, it's built for a lot of purposes. It can do almost everything except coffee. You have with these mobile platforms, it's not really built specifically for payment processing. So there's a lot of security features that have been integrated over the years to this mobile platform, but they are quite recent, and yeah, that is why we have seen very few initiatives about that. But however, the mobile acceptance is considered for everyone as by everyone as a growth driver, especially as a substitute for cash transactions. There are some verticals which are using a lot of cash for their activities. For example, taxis all over the world, they are using a lot of cash for the business, and mobile payment acceptance on the mobile platform could be a way to tap into these verticals as a substitute for this cash transaction, and especially for emerging countries. And it's also considered as a better experience both for consumer and merchants, and the advantages are numerous. For the consumer and merchants, better buyer experience, as I said, because for the buyer it's very easy to understand. You just tap your card on the merchant mobile phone, and then your transaction is processed. So very simple, just one step. And and for the merchants, it's also much easier compared to a traditional solution with a PTS device, and especially regarding the setup cost and activation. With such a solution on a mobile platform, you just have to download an application from an app store, and it's the same it's the same distribution channel as every other application. So it's very easy to understand for a merchant, and for the cost of activation is also really reduced compared to a traditional solution. As it runs on this kind of applications are also destined to run on the platforms which are widely available. Nowadays, even in emerging countries, smartphones are really are really distributed, so it's very easy to and everyone has access to them. So they are already there, and merchants in emerging countries, for example, are already equipped with this kind of solution. So it's a really good advantage for this kind of markets. As for the disadvantages, as I said before, there's quite a wide threat landscape which this kind of platform faces, and there's a lot of security concern and risk that are associated with them. Another downside is that without dedicated hardware, there's no possibility to print a receipt, and it's quite a disadvantages in this sense. Okay, so as we have said, mobile payments are on the rise. The solution for accepting payments on the mobile platform, they are not. What can the industry do to counter that? And actually, it's the job of one organization, which is called the PCI Security Standard Council, which was an organization created in 2006 to coordinate the standardization efforts that were made at the time on bettering the security of payments online, especially for e-commerce. And now their mission is to design requirements for payment system to make sure that the whole chain of payment will be secure, and that the consumers around the world can trust those payment systems. And their mission as well is to design, and that's what they focus their efforts this last few years, to design certifications, security requirements, especially for these mobile platforms. And we created two, which we'll go over in this part, which are the PCI CPoC and PCI SPoC. So what are the differences between the two? So first of all, the PCI CPoC was launched before PCI CPoC in January 2018, whereas the later was released in December 2019. And PCI CPoC are security requirements for a solution where the PIN is entered on the smartphone, but the card is read through another device. It's not using the contactless capabilities of the device, which is called the COTS, a commercial off-the-shelf device in the security requirements. With PCI CPoC, the COTS device is the whole solution, and it's a much simpler use case, which does not need another device. So two very different use cases. With PCI CPoC, you have, as I said, another device, which is called the secure card reader peripheral, which is plugged on the COTS device, and a PIN card holder verification method application, which is used to enter the PIN. So for CPoC solution, the application on the device only has one purpose, and it's to display a keyboard to enter a PIN, and use this PIN, send it to the SCRP, and then it's sent to the backend system. In the CPoC CPoC solution, the CPoC application does everything. And the capabilities of the COTS device are used to read the card. So here is a chart detailing the differences between the two. So just the key takeaways are that with CPoC, there's no specific hardware which is required, and there's no possibility of a software-based PIN entry. So on the next part, we'll go over of what is a CPoC solution. So we'll take the case of a CPoC solution which have a COTS device, backend system, and a contactless card. On the COTS device, you have the NFC interface, which is used to read the contactless card, and the CPoC application, which is installed on the COTS device, and its role is to do the interface between the NFC one and the backend system. And the backend system, they are really important in the CPoC solution, as they have three components: attestation, monitoring, and processing, which are really different, and we'll go over them in the next few slides. So here is an example of a transaction in a CPoC solution. So first of all, we assume that the CPoC application is already installed on the device, and now it boots up and it has to initiate a secure session with the backend system. Secure session means encrypted, and then now that that's it booted up, the backend system must now attest the integrity of the CPoC application, and also the COTS device if possible. But this component is to make sure that the CPoC application was not altered before contacting the backend system, so that to make sure that it maintains its integrity and that it has not been tampered with by a potential attacker. So this component is really important in the sense of a CPoC solution in terms of a security feature. Then we have the transaction per se, meaning that the data of a contactless card is read through the NFC interface. It's encrypted and sent to a backend system. And while this is going on, the backend system must monitor the COTS and application integrity. So same thing as before as for the attestation part. This monitoring components must examine if during the transaction there's no tampering attempts to extract card holder data. And once this has been done, once the CPoC application has read the encrypted data to a backend system, it can be processed. So what are the key takeaways from those security requirements? It's something that you have to keep in mind if you are developing a CPoC application. while you are still at the design phase. You do not have to implement these features as they are not in the scope of the CPoC security requirements, and it would take too much time to develop them as they are not necessary, and they will not be evaluated, and they will not be part of a final CPoC security solution. So first of all, online connectivity is mandatory. It's not possible to process offline transaction. And this is due to the backend system components. They are really important in the sense of the CPoC solution, and they are used to attest that when the transaction is operated, it has not been tampered with. So that is why online connectivity is mandatory in the sense of the security requirements. Also, it's only EMV contactless transaction can be processed. MSR contactless transactions are not permitted. At the moment, currently with the security requirements, there's no pin entry which is accepted, and there will be, but this has been met with a lot of drawbacks from the industry because they wanted to have a complete solution, as as no pin entry limits the use cases for this kind of solution. If with no pin entry, the contactless transaction capabilities are only below the threshold which are authorized by the market. So 50 euros, for example, for the European Union. But yeah, it greatly limits the use cases for this solution. So that's why the PCI Security Standard Council heard the industry, and we are currently drafting a new standard, which is PCI CPoC with PIN, which we hope will be released next year. The first draft is estimated to be released by April, with several requests for comments around. And of course, another thing to keep in mind is that beyond the developing the application, the features, and implementing the security requirements, there's also processes and methods that you have to implement in your organization, so that that are part of the security requirements. So, for example, secure coding practices, which are there to make sure that few vulnerabilities will appear in the final applications. To implement as well in vulnerability management and technological watch management programs, which are important because if a vulnerability is found in the wild by security researchers, you have to have the methods and processes to triage, read, and implement the patches to correct the vulnerabilities that have been identified. And this is in accordance with a new PCI software security framework, which which is another important part of the certification process for CPoC. Okay, so now to the security challenges. So those PCI CPoC security requirements, they assume a threat scenario, meaning that this is the possibility of what could happen if an attacker would attack the solution. And in this case, it's the worst possible case, and the attacker has full access to the platform, both the application and host device, because as it's a widely available solution, you have the host device which you can buy, and the application, it's assumed to be also downloaded from the App Store. So one could just download the application, try to tamper with it, as well as the host device. So it's a worst possible scenario. And it's also assumed that as the application, as everything is done in software, there's also the possibility of remote attacks. So it's local and remote attacks, so the worst possible scenario in the security sense. As for the possible attacks, you have example. So an attacker could perform side channel attacks, static analysis, dynamic analysis, reverse engineering methods, which could be used to understand how the application works, how the solution works in all of this, and try to extract some information, especially cardholder account data, which could be interesting for a potential attacker. So what are the security objectives behind these security requirements? So first and foremost, it's to preserve the integrity of the NFC interface and the contactless kernel, which are the one which are the components which are reading the card. So they are at the forefront on this part. One of the other security objective is also to reduce the attack surface of the whole solution. Make sure that there's little possibility to attack either the application, the host device, the NFC kernel, or the backend system. And the main goal of all of this is to protect cardholder account data. So to make sure that these objectives can be achieved, there's two things that are implemented. So first of all, it's a design, and it's the isolation of cardholder account data, and that's why there's no PIN. And if an attacker would have access to the solution and intercept data, it could only intercept some parts of what constitutes an identity of cardholder account data. It could only access, for example, the credit card number, but not the PIN, limiting then the use cases for fraud. And also the security features, which are spanned on the whole solution. And that is mainly why these requirements are quite long, 162 pages long. It's because they are security features which are present on the whole solution, both the attestation part, the CPoC application, cryptographic keys, and such. Here we will focus on what is supposed to be implemented in securing the application. So just as a reminder, the CPoC application, its purpose is to read the data, encrypt it, and sending it to the backend system. So it's for this mission, and make sure that an attacker could not try to reverse engineer or tamper with this application to extract the interesting data. The CPoC requirements mandates to implement software protection mechanism. And also the cryptographic operations, as the CPoC application must encrypt the data. Those operations must be protected either through using security features, such as the one provided by a trusted execution environment, or by software. And for example, by using white box cryptography. There's also something which is not in the CPoC requirement, but if you're operating in the European Union area, you also have to take into account the consumer data protection. And in this sense, it's better to encrypt everything, both at rest, in transit, and in use. Another component of a CPoC solution are the backend system, and they are crucial in this sense, because their purpose is to attest that the device and the application has not been tampered with, monitor the transaction during its execution, and then send it to processing. For the security features, the attestation and monitoring system, they must be completely independent from the processing system, because an attacker, for example, could probe the API which is offered by the attestation and monitoring system and try to attack them. As they are exposed to the internet, they are also exposed to a potential attacker. And so that's why if they are corrupted or attacked by someone, processing systems are independent, and then only a link in the chain is exploited, not the rest. Also, the attestation elements on the codes device must be protected against reverse engineering. So you have attestation elements both on the servers and on the devices. And these attestation elements which can be part of the application must be protected against reverse engineering and embed some software protection mechanism. And to do so, to protect these security features and to implement the security features, one could use application hardening or application shielding, which we will go over in this next part. So what is application hardening? It's mostly solutions, techniques, technologies to defend an application against reverse engineering. And there's several solutions that can be used. So for example, one could use code and data obfuscation. So obfuscation is a means to scramble code and data so that if an attacker would try to understand the program logic, it would be very difficult to do so. And here are a few techniques which could be used to do that. So for example, insert dead code into the software source code, code which does not do anything, but which would take time for an attacker to understand that indeed it does not do anything. Another mechanism is our anti-tampering mechanism, which are there to make sure that the application is not an attacker is not currently trying to understand how it works. So for example, anti-debugging detection or anti-hooking detection, which are frameworks or softwares which are used by attackers to understand how an application is currently, what the application is currently doing while executing. And there are also security features to make sure that the device and integrity has not been tampered with. So for example, that the device has not been jailbroken for an iOS device or written for an Android device. And that is actually solutions that we can offer to mobile application developers which are currently designing CPoC application. And we have these three products which are used to protect code, data, and keys running on this kind of untrusted environments. So we have three components: Epona App Shield, which is an application hardening component, which proposes those two functions that I mentioned earlier. And there's also we have also Epona Key Shield, which is a white box cryptography module, which can be used in the sense of a PCI CPoC solution to protect the cryptographic keys that will be used by the CPoC application. But the last one will be the most interesting in the sense of a CPoC solution, which is the Epona Digital Vault. And these components uses the hardware security components when they are available. So for example, the security features which are offered by a trusted execution environment. And if they are not present on the device, it uses white box cryptography. So it's the better of both worlds. And actually, this component can help you achieving a very fast time to market while complying with the PCI CPoC requirements. Because when using this component, you can make sure that you have your application will run on a larger set of devices, uses the hardware security components when they are present on the platforms, and if not present, default to white box cryptography. So it's a better security overall. So these components, they can easily integrate into your existing CI/CD. So you do not have to do heavy modification to your application. If you are already advanced in the development of your application, this can be a bolted on security. You just have to integrate them into your CI/CD, and then it's done really quickly. Okay, so that is time to conclude our webinar. I hope you have enjoyed the presentation, and we will now go over the question. Okay, so I think we have questions in the chat. Why is there a need to store keys on the codes device? It's actually there's no really a need to store keys on the codes device. It's just that cryptographic operations, in the sense of the CPoC solution, must be protected. So if one one attacker could be using, for example, side channel attacks to understand how which can be used to extract the key used in for this operation, and that could pose a security risk. Okay, so next question: does Epona contribute to ensure device and app attestation? This is not a feature that we have right now. So we do not have these features in our software. Okay, we do not have maybe any late question. Nope, I think that's it. So it's time to conclude our webinar. Again, thank you for assisting to this presentation. If you want to go more over on this subject, we have written a white paper about securing mobile payment application, which goes beyond the scope of PCI CPoC, which you can download and by going to this address, go.quarkslab.com/mobile payments. If you have any inquiry regarding the subject of the webinar or any other question, please send us an email to contact@quarkslab.com and we will be happy to answer. And if you want to keep up to date or know when will be the next webinar, you can follow us on Twitter and LinkedIn with the @quarkslab mention. Again, thank you all, and have a great day.